So for 2015, our model was this this little shape here. So what we do is we sit you down in a booth, give you a hard copy drawing, and say you have to model this part. We also give you a little rapid prototype that Schneider has printed up for us. Really, just to give you a general visual of what the part actually looks like. This part here is fairly axisymmetrical. So if we look at some of the features on this part, actually we'll get into this. So what we do is we give you this drawing. Then what we do is after you complete this drawing, model this part, not creating the drawing, just model the part, we give you this change to make. So you have to make a change and then run a quick simulation that's identified up here. And then whoever does it fastest time wins. So let's take a look at our model and just get a general understanding of how we might approach this thing. So if you look at it as a fairly axisymmetric part, you know, if we create all this information over here, we can pattern it around 3 by 120, everything's equally spaced. We also have this pocket in here. So if you look at the section view, how this pocket was created, we have all that information defined as well. So without further ado, let's jump into SOLIDWORKS and show you how to approach this. So I'm just going to start by drawing some circles. So first off, we'll start by keying in 50 for this one. So one of the things you might notice is I have this sketch numeric input turned on. This is one of the things that I use quite a bit, and I think it's really useful. If you go under the sketch settings, you have enable on-screen input on entity creation. So for lines, rectangles, circles, arcs, and things like that, it allows you to put in a numeric input and it automatically creates the dimension when you have that, when the value is entered. So if you have these two checkboxes, it can save you a lot of time when you're, you know, creating geometry. So let's create another circle here. This one's going to be 60, and I'm going to create one more circle. This one's 75. This one is just going to be construction geometry. That's my bolt circle that goes around the outside there. And I like to use a lot of construction geometry. It gives me a visual context of, you know, what this is. Usually I see a construction geometry, I know it's some sort of reference information that I need to be able to use. The next thing I'm going to do is I'm drawing the center line from the center out to here, just to kind of establish a center line, give me a vertex right there, and also allow me to capture some symmetry. Next we'll add a circle, and this is going to be 10. And then I'm going to draw that boss that goes around here. Now the way I'm going to do this, there's a couple things you can do. Notice as my mouse comes off of the arc, it comes off tangent. I might not always like that. So if I go back and retouch that circle or that arc there, I can bring it off straight and just kind of draw a regular arc. Also notice that as I go back to the vertex, when I'm drawing this arc, I'm sorry, I was just drawing a line. When I go back to the vertex, it automatically switches to arc. So that's kind of a little time saver, saving you from having to go pick a new command. And then continuing on, I'm going to draw another line, and we'll make that tangent. So you can see I captured tangency while I was sketching in both cases, and then I have the coincident relationship as well. These two arcs right here, I need to make those concentric, and I need to add a dimension. This is going to be 8. And then the only thing left is to add some symmetry, add an angle dimension. So I want symmetry between these. Grab those 3 items, create that symmetric, and then, oops, click that one, and we'll make that 30. So my sketch is fully defined. Now, you might ask, why did you put everything in one sketch? It's something that I tend to do a little bit more. I like to use our contour tools that are inside of SOLIDWORKS. It allows me to capture all this information in one sketch, quick and dirty, get it done, and then I can leverage it and use it in various places down the road. Next, we're going to extrude it. What do I want to extrude? I'm just going to extrude this contour here. I want to go about the mid plane, and I want that to be 20 millimeters. So there's that first feature. Next thing, we'll take our same sketch and extrude it as well using the contours. Choose this contour. I want to go about the mid plane. 20 is already entered in there from the previous extrude. I'll hit OK. Pretty straightforward so far. I'm going to add a fillet, so I'm just going to grab that edge, use the fillet tool. It's going to be 8, key in 8, and I'm just going to select this edge right here. Accept that. Now, if we come back over to our drawing, we're going to need to make this pocket. So you see this little pocket here. It's got rounds on the edges. It's defined with 45 and 90. Several ways we could create this, and I'm going to show you those ways. I'll show you the last way is the way I actually create it, but I'll show you a couple different techniques that you may use down the road. So One of the ways is I could jump on my front view here and then just come in and draw maybe a rectangle like this, and then I could take that and revolve it about that center line 45 degrees in each direction, or about the midplane. That's one way to do it. It's not the way I chose to do it. I like to keep things fairly simple. Another way is, if I jump to this part here, is to use a swept cut. Now, if I do it this swept, or just a regular swept cut, and draw a rectangle on the end, I'm still going to have squared off corners. But maybe something that a lot of people don't know about is when you're creating a swept cut, you have the option to create a solid sweep. So in this case here, I choose this body. So this is a multi-body part, so I didn't merge these two bodies. Made sure I didn't do that. All I did was define an arc, this arc up on the top, on that top plane there. And then I created a plane. Let me actually jump out of here. So I created this sketch. And again, this might be a little bit more work, but it's an interesting technique that you might want to use. So I just created a sketch on the top plane. I created another plane that was through this point and tangent to that outer boundary there. Then I created this boss, which is extruded in two directions, and I chose not to merge that. So I have two bodies, multi-body part here. So back to the swept cut, and we're going to choose the solid sweep option. So I choose the body I want to sweep, and then I can choose the arc as well, and then hit OK. And you can see what that does is it takes that body and sweeps it around that arc and puts, the rounds on each end. You got to create a sketch, a plane, the boss, and a cut, that cut sweep. You could argue that's a pretty efficient way to do it. It's not the way I did it. I just wanted to make sure that everybody knew that we have the swept cut, and it can be useful in some cases. So let's go back to the part that we were originally working on and show you the way that, like I said, I like to keep things simple. So let's jump to our top plane here, and I'm just going to draw in some lines from here to, say, here, and then I'll draw a vertical line. Let's connect all this stuff up here. That's kind of ugly. It looks like when I drew, I captured perpendicularity. That's okay, or I can add a dimension, but that's just the way that I drew that one. I'm going to draw a center line in here, and I'm going to come out and pick up that midpoint. So I'm making sure I'm picking up the midpoint. Now, I picked up the midpoint, but it didn't capture this to be horizontal. So making that horizontal then gives me my symmetry. So now my part is symmetric. I have perpendicularity there. That gives me my 90. And then we'll use this to create an extruded cut. And I'm going to go about the midplane, and that's going to be just 10 millimeters thick. So once I have that, so now I got to create those arcs on the inside there. And in order to do that, I'm going to use the full round fillet. So this is a very cool command here. It asks for 3 faces that you want to create a full round to. So I'm just going to choose this face. And then if you notice on my mouse, I have a little enter on my right click. That takes me to the next control box over here. So it keeps me from having to move my mouse back and forth. So I'll click this one, right click, enter, click this one, right click, enter, and I have that. Hit the enter key, brings up this previous command. Click this one, right click, enter, click this one, right click, enter, click this one, and there we go. So we have our full rounds, we have all of our features there. The next thing we need to do is just pattern this around our part. So we'll create a circular pattern. I want to pattern it around the inside. Make sure you have 3 of them, equally spaced at 360. And there's the geometry is done. Now, one of the other things we ask on the drawing is to make sure that you put in the material. If you don't put in the material, it's not 100% correct. If you've done this and actually gone to the contest, I always make sure that the material that's assigned is on your favorites. So if you don't know how to add these favorites, just come into here, manage favorites, and then you can have your own list of favorites, that materials that you use over and over again. So that's kind of cool there. So there's phase 1. So you get that done, and you're ready for phase 2. So once you're done with that, what we do is we give you a second drawing sheet. Now, if you look what happened here is, we started on the top view and we started modeling all of our information in over here. Now what we're doing is we've basically said that boss is gone, but these remain, and now I have to remodel this information in here. The other change we have is we now need to increase the opening of that pocket that we have in there. So instead of 45 each direction, or 45 and 1 and 2 times 90. Now I'm 90 from here, and that happens on the top and bottom. So you can see how that face has changed there. So how are we going to, and then we have the simulation, and we'll walk through that as well. But so how are we going to approach that? I have a couple different techniques that we can use. If we go back and look at the drawing, one of the ways we can do this is I can do hack and whack and just hack away all this material and then remodel it back in. That's pretty good. I can change the pattern. Instead of two equally spaced, three of them equally spaced at 120 or around the 360 degree total, I can make it 2, and then this one will be gone, and I can start modeling that in down there, and the orientation of the part doesn't necessarily matter as long as the geometry is correct. So those are two techniques, and I'll show you. I actually went through and did some of these, and I'll show you some interesting things or benefits of doing it one over the other. So this is the hack and whack method. So the first thing you got to do is you got to come in and create a sketch, then create a feature and cut it away. Then you come in and you resketch that material on top and you add the boss. So that's one way, and then you put your boss on out there. So that's the same as the way I will actually approach it. Another way to do it is the making a pattern change. So here I have my circular pattern. A couple ways I can approach this. One of them is just click one of these pattern features, or maybe the last one over here, and hit the delete key. As soon as I hit delete on a pattern instance, it asks me, do I want to delete the whole pattern feature or just the instance? So I could have chosen to delete that pattern instance, cancel that, or another way to approach this is to come in here and just to say, don't uncheck equally spaced, and we want 2 of them at 120. So that's okay there, but now what I need to do is I need to create a sketch. If I come to my top view, create a sketch at, on the top view and put that information in there, and then I got to add that boss. Then I got to add my fillet on the end, so there's another full round fillet. Then I got to add that cut as a separate cut, and then I got to add these fillets here, and then my cut. So in either case, we're going to be always creating these. And then I got to come in here and change that, and I'll show you, the best technique for doing that. So either way, this seems like a lot of work. You got 3 extra sketches and 5 features. In my opinion, it seems like a lot of work. So let's go back to our original part that we started with. If I jump to a top view here, you'll see this is the one we want to cut away. So when I first look at this, the first thing I think is I want to use the delete face command. I want to delete all those faces and just have that nice and smooth across there. So a couple ways to approach this is I'll come in here and just say select tangency, and that gets all those faces there for me. Then right-click, hit the delete face key. This is something that delete face and move face are 2 direct editing type of tools that I use a lot, and I tend to always have them customized onto my right-click. So make sure that if you for your general use, that you click the checkbox so that these come up on your right-click all the time. So I'm going to hit delete face. And sometimes when I delete face, I'll take this in steps. I'll take baby steps or small bites at it, and I'll say, delete face, yeah, that works. I can come in here and create another delete face, or just edit this one and say, I want to take these holes out. And actually, for this particular model, I can delete all these faces like this in one shot. So it takes them all away. So a single command, I'm able to do that. Now that was pretty quick and easy. If I show you another quick little method for selecting all those faces, hopefully I'll just clear the selection here. Hopefully this will help. So if I just wanted to say I want to grab all these faces right here. So I didn't do a very good job there. Let's clear the selection. I'm just going to window select all those faces. So one of the things you'll notice is it got some of them but not all of them. So faces that are hidden, it didn't pick those up. Well, that's not good, and I got to still come in and manually select. So what I do is, when I'm trying to do something like this, is if I go to wireframe and I window select like this, it's going to grab all those faces because nothing is hidden, and then hit OK. So quick and dirty, if you just window select, go to wireframe. If you know you need to grab a lot of faces, and you can turn on your filters and stuff too. Those definitely help. But if you know you need to grab a lot of faces like that, might consider trying to go to wireframe, and that way, since nothing is hidden, you're able to select all those faces. So a single command to get rid of that. I'm just going to jump to a front view here, and then we're going to sketch on our front plane, And I'll draw in a line, say from here, and I'm going to come up here. And notice as I'm drawing inside of this part. So I didn't choose to grab this silhouette edge here. I chose to do that inside my part. And the reason is because if I extrude this in both directions, I'm just going to have a single edge of contact there, and that's not going to work too well because SOLIDWORKS doesn't like that singularity there. So we need to add a dimension between the center of our item and the center of our part, so 40 millimeters there. And then finally I'll add just a circle, 10 millimeters, like that. I don't really care about this. I could add a relationship to that edge in this point here, make them pierced or coincident, but it's just extra work for me. So we'll extrude this about the midplane, and I want this to be 12 millimeters. Okay, on the top plane here, I'll create a sketch, and the way I'm going to do this is I'm just going to draw a line from here out to there, and that's it. A single line. I'm going to use an extruded cut. I want this to be a thin feature. I don't want to go in direction 2, and I want the thin feature to be about the midplane of 2. I want this to go through all, so I get a nice preview, let me know when I'm going. So just a single line, and I'm able to use the thin feature at 2 millimeters to create that saw cut through there. We need to add a fillet here, so this is going to be 6. We'll add this one as well, so those are 6 and 6. And that part of the geometry is done. So we did that with a delete face, 2 sketches, 2 features, and a fillet. I thought that was the most efficient way to approach that, and it's fairly simple and straightforward that everyone can understand it. Next thing we need to do is we need to deal with this right here. So let's jump back in here. I'm going to choose this face. Well, like explain a couple different ways. Some people did this and they just hacked all that material away and redrew a line in at 90 degrees and then reapplied their full round fillet. That's perfectly valid, but it's, you know, it's creating a sketch. It's adding the feature, it's creating another full round fillet, and then having to do it on the other side as well. One of the best ways to do that, in my opinion, is to use the move face option. So I'm just going to grab the move face. You have the ability to offset that face, translate that face, or rotate that face. In this case, we want to choose rotate. I want to rotate it about my temporary axis right here. And let's just make that 45. So 45, I get a nice preview of what it's going to look like. Single command, I was able to move that face an additional 45 because it's now 90 from the center of that circle. So we'll do the same thing over on the other side. Use the move face command about that axis. And as you notice the preview, I'm going to flip my direction, make sure I'm going in the right direction. That's going to be 45 as well. And there you have it. All the geometry is then done. Let's jump back to our drawing. So now we say we need to run a simulation and calculate the factor of safety for this part. So we need these 2 faces right here get fixed. 1,000 total load on these 4 red faces, and it gives you the load direction. So let's walk through how to do that. Now, one of the things that had I used the version, oops, let me go here, where I actually did the pattern change. So I was able to create this same thing with the pattern change. But if I jump to a top view here, notice that the direction of my load is now going to be going in this direction. If you're using SOLIDWORKS Simulation, that's not a problem. If you're using SOLIDWORKS Simulation Express, we don't allow you with Simulation Express to choose an edge as the load direction. You have to have a plane. So in that case, then you're having to recreate a plane to get your load direction. It seems to be a little bit more work to use the pattern change option. So let's go back to the model that we're actually working on here and show you how I did this. I prefer to use SOLIDWORKS Simulation as opposed to Simulation Express. You can choose whichever one you want. Just create a static study. We're going to need to add our fixed geometry. So we'll choose this face and this face. And then we'll add our load. So we're just going to add a force to here, 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 and here. I want that to be in the selected direction, and I can just choose an edge. So in SOLIDWORKS Simulation Express, again, we're asking you to choose a plane, and that's fine if you do it this way because you have your reference planes that you can choose from. But I'm just going to choose an edge because I don't feel like turning my reference planes on. and I want it to be total. I want it to be 1,000. Check make sure your arrows are pointing in the right direction, so I'm going to reverse that direction, and there we go. Last thing I need to do is hit run, and SOLIDWORKS will solve. And I always like, one of the things I always like to do is I like to animate my results. And the reason I do that is because I want to make sure that it's behaving as I expect it. Had I not chosen maybe one of these faces and the thing might be pulling away, I would go back and rework with my loads or my boundary conditions to make sure that I got that quite right. So it's always a good idea to animate your results and just to get a very good feeling. Factor of safety is a plot that I have created by default, and certainly in for the setup for the contest, we have that plot being created automatically as well. Get about 4.25, 4.26 or whatever is our factor of safety, and that was the answer for this Model Mania Championship. So you had to get everything right, the material, phase 1, phase 2, and then your factor of safety, and then we judged on time. So that was Model Mania 2015.